Welcome to Lesson 9, the one you'll actually need at 2 a.m. Picture it. The container has restarted 3 times, customers are angry, and you don't have time to read a tutorial. What you need is 4 commands: logs, exec, inspect, and stats, and a calm process for using them. That's the triage toolkit, and that's this lesson. So here's where we're headed. 4 skills, 1 workflow. First, reading logs properly, live tailing, recent windows, filtering down to what matters. Second, execing into a running container so you've got a shell to poke around in. Third, Docker inspect, which hands you the container's full state: IPs, mounts, env vars, restart policy. And fourth, Docker stats, for catching the runaway process or the memory leak in real time. Master these 4, and you've got the muscle memory. And before we touch any of those tools, here's the order to run them in. When something breaks, resist the urge to Docker rm-f and start over. That just destroys your evidence. Instead, ps to see if it's even running and what exit code it threw. Logs to read what it printed on the way down. Inspect for the full state. Mounts, env, network, and exec to climb inside and test things by hand. Same 4 steps, every failure. So step 2, Docker logs. And really, 6 flags do almost everything you'll ever need. -f follows the stream live. That's your daily default. -- tail caps how far back you read so you're not drowning in a million lines. -- since and -- until carve out a time window. Perfect when you know roughly when things went sideways. -t prepends timestamps if your app forgot to. And the old bash trick, 2 greater than &1, merges stir into stout so nothing hides. Filtering is the whole skill here. Step 3 is Docker exec. Basically SSH into your container, except there's no SSH daemon involved. You can fire a one-shot command, like listing a config directory, or pair it with -it to drop into an interactive shell and poke around. Once you're inside, you can ps, cat configs, ping the DB service, curl the API on the internal network, all the things you'd do on a normal box. Quick heads up on shells, though. Alpine ships not bash. Debian and Ubuntu give you bash. And distroless or scratch images. No shell at all. You debug those from the outside. Now let's talk about what actually breaks. 4 scenarios cover roughly 80% of container failures you'll ever see. If it crashes on start, Docker logs tail 50. The error's almost always right at the top. Missing env var, port collision, file not found. If it starts but won't respond, exec in and check from the inside. If curl works locally, your port mapping is wrong. Can't reach another container? Ping by service name. Unknown host means wrong network. Timeout means firewall. And if it's slow or getting killed, Docker stats shows you memory leaks and runaway CPU in real time. Let's zoom in on those last 2 tools, because together they answer almost every "why is it doing this?" question. Stats is your live view. CPU, memory, network, refreshing every second. See that API container at 93% memory? That's an kill waiting to happen. Inspect is the opposite, a full JSON dump of how the container was configured. Use the -f flag with a Go template to pull just the field you need. Exit code, health status, restart count, IP address. Stats tells you now. Inspect tells you why. Once you've got the basics down, here are 6 moves that separate the seniors from the rest. Pipe logs into less so you can actually search them instead of scrolling forever. Docker CP moves files in either direction. Pull a log out, push a fix script in. Compose logs -f tails multiple services side by side, which is gold for spotting timing issues between web and DB. Netshoot as a sidecar gives you TCP dump and dig inside another container's network namespace without rebuilding anything. Docker top shows processes in one container, and Docker events replays everything the daemon did in the last 10 minutes. Every start, kill, and in order. So here it is, 12 commands, 1 page. Print it, pin it, screenshot it. Top row is your eyes. Piece to see what's running, logs to hear what it's saying. Middle row is your hands. Exec to step inside, inspect to read the blueprint. Bottom row is the deeper cuts. Events, stats, CP, port. For when the obvious answers don't add up. When the pager goes off at 2 a.m., you don't think. You just reach. Now, before we wrap up, let's talk about the habits that quietly sabotage you. 5 mistakes, every one of them invisible until somebody points them out. Restarting before reading logs erases your evidence. Logging to files inside the container means those logs vanish the moment it does. Reaching for Docker rm-f as a debug step kills the very thing you needed to inspect. Running Docker logs without tail or since floods your terminal. And misreading exit codes. 137 is out of memory. 143 is SIGTERM. 1 is your app. That knowledge alone saves hours. Now it's your turn. 3 exercises, each one a real failure waiting to happen. First, run Postgres without a password. Watch it crash, then walk the flow. PS, logs, fix, restart. Second, get inside a running Nginx with exec. Poke around the config and run nginx-t to validate it. Third, open Docker stats in one terminal and starve a container of memory in another. Watch that exit code 137 show up right on cue. Do these once, and the muscle memory starts forming. And that's lesson 9. You've got the 4-step triage flow in your hands now. Piece, logs, inspect, exec, plus stats, top, and the exit codes that tell you what really happened. Things will still break, but you won't panic because you've been here before. Next up, lesson 10. We stop fixing images and start sharing them. Docker login, tag, push, Docker Hub, GHCR, private registries, all the same shape. See you there.